All right, so our next speaker is Mark Swain, and he is going to talk to us about Ariel. Pointer, that's the laser, and that's forward.
Laser and forward, okay.
Pseudo laser, it's the electronic.
Sound check, are we good?
Yep.
Excellent. So it's the end of a really interesting meeting and a really interesting week. So if you'd like to tune out and take a nap, I'm good with that. To enable you to take that nap, I want to leave you with two things, so you can go to sleep now and wake up for the last talk.
Mark, that side of the line.
This side of the line, okay. The two things are, Ariel is a mission which is going to do a marvelous uniform survey, a statistical survey of exoplanet atmospheres. And yet, we don't really know what it'll do. So we'll come back to that second part in the second part of the talk. Ariel is really designed to look at some of the key foundational questions in exoplanets that require a statistical approach to address. And these are questions which are, they're really the type of big picture questions which resonate with everyone. We know now that when we look up in the sky that there are more planets than stars. And so questions like where do planets come from, how do they form, how do planets and their atmospheres evolve are some of the questions that lend themselves to addressing in the context of a statistical survey. I don't have much time to tell you about Ariel, so I'm leaving you with some links. Those are links you can go to find out more about the mission. So I'll turn now to kind of a high-level summary. Ariel is the ESA M4 mission, so it follows Plato. The prime mission is going to last 4 years, and that includes some on-orbit checkout. Let's see, the laser. Here we go. Okay. Big point about Ariel is the broad instantaneous spectral coverage. All right, so when Ariel observes, there's one mode. We look at hundreds and hundreds of exoplanets, exactly the same way. And we get a spectrum from 0.5 microns to 7.8 microns all at one shot. So we don't need to stitch multiple transits together to get the full wavelength coverage. And again, the main objective of the mission is the statistical study of exoplanet atmospheres. The payload for the mission is built by this consortium of 19 national partners. Our PI is Giovanna Tenetti, who's a professor at University College London and who couldn't be here today, so I'm standing in for her. And we have some US participation in Ariel through the CASE project, which is a mission of opportunity funded under the NASA Explorer program, and also an Ariel Science Center that's recently been stood up at IPAC, and you should address questions about that to Dave Ciardi. But both of those are good opportunities to potentially get involved in the really exciting science that Ariel is going to do. The CASE contribution is centered on hardware, but we also have a science team and some science data processing we do. For this contribution, we're contributing detectors, the cryogenic cabling, and cold front-end electronics, which digitize the video signal coming off the detectors. CASE provides this capability to the fine guidance measurement system, which is one of two primary instruments on Ariel. The FGS is a dual-use instrument. Part of it does science, and part of the measurements are used for stabilizing the spacecraft line of sight. So let's see where CASE fits into this overall picture. Ariel has a meter-class telescope, and I've got a visualization of that. You can see the telescope and its shroud are nestled in radiation baffles. It's primarily thermally cooled with some active cooling for some parts of the instrument. The main science instrument is the Ariel spectrograph, AIRS, which covers wavelengths from 1.98 to 7.8 microns. And then the fine guidance system, where the CASE detectors go, has these 4 channels, 3 photometric channels and 1 low-resolution spectroscopic channel. So an Ariel measurement would look something like what I'm showing on the left of the screen. So this is a simulation of what's called a Tier 2 measurement. We'll talk a little bit about that in a minute. So we get this broad instantaneous spectrum. And that spectral coverage enables detection of a whole bunch of diagnostic molecules which probe the conditions, the composition, and the chemistry of exoplanet atmospheres. So up until this spectrum measurement, what I hope to have communicated to you is that there's a highly optimized, well-understood, beautifully designed mission that will deliver this uniform set of measurements. What we don't know is exactly how we're going to use it. RL has a tiered survey strategy. So in Tier 1, we're supposed to do a lot of planets with less sensitivity. In Tier 2, we do a subset with higher sensitivity. And the thresholds for this are fairly, they're nominal definitions for that now. But we still don't really have an understanding of how we're going to divide the mission candidates up between emission spectra, transmission spectra, and phase curves. And so this is actually a real opportunity, and there's a big discussion in the consortium, which is trying to address how are we going to optimize the science return, what fraction of the time do we look at what kind of targets. So that conversation's just starting, and I'm sure it'll be going on for several years. But what I'll share with you now is some of the simulations we've been doing inside of the CASE team to contribute to that dialogue. So within the CASE team, we've decided to concentrate on looking at what would be possible with a Tier 2 level sensitivity for transmission spectral surveys. So we had to make tons of assumptions. One of them was we only used existing targets, and of course we know that more targets are going to be discovered. There are tons of follow-up programs going on right now. So we're just limiting this to existing targets. And we couldn't use the whole RL mission on this. So we've, again, subject to some assumptions, we came up with a Tier 2 sample, which is about 250 planets. These are selected based on metrics like the TSM. And these basically selecting just based on metrics for the transmission spectra alone gave us pretty good sampling in the mass radius space. The way we then simulate the mission performance for this survey is that we take these planets and that we build a theoretical model for the transmission of spectra of the atmosphere. So we do a forward model based on equilibrium chemistry. Again, this is kind of a first order study, and so perhaps later on we'll be able to make that more sophisticated with some non-equilibrium chemical models. But for present purposes, we use equilibrium chemistry. And I'm showing an example of that on top for one of the targets in this ensemble. Then we use an instrument model. We use the RL-RAD model, which incorporates the current best estimate of exactly what the RL capability will be. And these gray points in here are actually the individual pixel-based spectral channels with the measurement uncertainties. So an RL Tier 2 spectrum is really good. Then we do retrievals on the entire ensemble to retrieve the model parameters. So it's a classic injection recovery kind of test. And for this narrowly focused study, keep in mind there are lots of different things that we could potentially look at, but we're just starting. So for this narrowly focused study, we chose to look at one of the diagnostics of exoplanet formation type models, which is the carbon to oxygen ratio. And we look at how well we recover the C to O that we injected based on the simulated observations. And this is pretty interesting. What we find is for this Tier 2 survey, we're able to get a median C to O uncertainty of about 0.1 to 0.2 dex. So that's really good. We were very pleased with that. I think REL is going to be able, potentially, depending on exactly what it observes, but I think it's going to be able to make some pretty powerful statements about planet formation model testing. And so that's, again, this is just one aspect of many studies that will be done over the next few years to try to define exactly what the mission's going to look at. So there are a number of REL preparation activities, and if you want to get involved, there are several different options. I'll draw your attention to the first one on the list here, which is Exoplanet Watch, which is led by Rob Zellum, who just gave a talk here. Oh, there he is. So Exoplanet Watch is this really cool activity, which is essentially a data processing engine that does both processing and data fusion, and it enables citizen scientists and students, professional astronomers to contribute light curves for ephemerides maintenance for transit targets. There's kind of a similar effort that's parallel in Europe, the Exoclock project. Of course, finding new planets, and here I'd highlight test follow-up activities, and a number of the Case Science team members are very involved in that. Finding new planets is very important, and stellar characterization. And particularly for the people at this meeting, there is a Ariel working group, and that's the link to it, for stellar characterization. NASA also has a proposal opportunity. I think you had to submit an NOI already, but I know several people, I'm not part of this, but I know there's several teams already preparing proposals for this, this upcoming deadline, and I think it's envisioned there'll be further opportunities down the road. Anyway, if you're interested in getting involved, please feel free to reach out to me, and I'd love to talk to you and help figure out something that you're interested in doing that contributes to the mission. So I'll leave you with this picture of Ariel. I hope I've convinced you that we don't know exactly what Ariel will do, but we know it's going to be pretty exciting. Thank you very much.
All right, are there questions for Mark? I know it's late, come on. Oh, way in the back.
Thanks for the talk. Are there good public tools to simulate the spectra that you showed sort of in the middle of the talk where you were doing those retrievals?
There are not public tools at this, well, I take that there may be, but these are not secret. I mean, they're not loaded up on a server where you can get them, but in the context of collaboration, I'm happy to share our synthetic spectra. There are other teams in Europe that might be able to help you out also, but I'm happy to share these. I think there's an SNR calculator, but I'm not sure there's a forward model calculator just yet. But again, if you're interested in these, that's something we can talk about.
Thanks.
Other questions for Mark? All right, well, let's thank Mark again very much for his presentation. Mark.